Welcome to Senior High School Math Series. In this video lesson, we're going to discuss regions under the normal curve under Statistics and Probability, Quarter 3, Week 4, based on Curriculum Implementation and Learning Management Matrix for K-12's most essential learning competencies. Here now is our learning competency. Identify regions under the normal curve corresponding to different standard normal values. Let us begin with ponder on this. In other fields of mathematics, you learned that curves are represented by mathematical equations. The circle, probably the first one to come to mind when you hear about curves, is represented by the equation x squared plus y squared equals r squared when the center is at the origin. In here, r is the length of the radius of the circle. The size, therefore, of the circle depends on its radius or diameter. Like circle and other curves which are used in engineering, design, and other important applications in life, the normal curve is represented by a mathematical equation, and its size and shape depend on some parameters. The shape and position of the normal distribution curve depend on the mean and standard deviation of the variable. A normally distributed variable has its unique normal distribution curve. The larger the standard deviation, the more dispersed the distribution is. If two normal distributions have the same mean but have different standard deviation, they may be located at the same spot on the horizontal axis but will have different spread. Now, if two normal distributions have different means and have the same standard deviations, then these distributions may be in different locations on the horizontal axis and have similar shapes. With the mean, standard deviation, and specific scores or percentages known, many real-world problems may be solved using the standard normal distribution curve. For instance, if we know the standard deviation and mean of a certain examination, the variable is normally distributed, we would know the probability of whether a randomly selected examinee was able to get a specific score or a range of scores. For real-world problems using the standard normal distribution, solutions may be done using a recommended procedure. First, draw the figure showing the desired area. Next, use the appropriate figure and follow the direction. To the left of any z-value, look up the z-value in the standard normal distribution table and use the given area. To the right of any z-value, look up the z-value in the standard normal distribution table and subtract the given area from 1, since the total area under the normal distribution curve is equal to 1. Between any two z-values, look up the z-values in the standard normal distribution table and get the difference between the two areas. In this video lesson, we're going to use that standard normal distribution table with two parts, the one for the negative values of z and the other for the positive values of z. The standard normal distribution table gives the area under the normal curve to the left of any z value given in two decimal places. For example, the area to the left of a z-value of 1.76 is found by looking up 1.7 in the left column. Remember to use the part of the table that gives positive values for z, and 0.06 in the top row. Where the two lines meet, This gives the area of 0.9608. Hence, the area to the left of z-value equal to 1.76 is 0.9608, or we say 96.08% of the area is to the left of z equals 1.76. Let us have an example. Find the area under the standard normal distribution curve to the left of z equals 1.85. For our solution, first we draw the figure showing the desired area, the standard normal distribution curve, and since the value of z is positive, then it is to the right of the mean, or to the right of 0. So we have 1.85. The area is shaded, that is to the left of z. The next step is to look for the area under the standard normal distribution curve using the standard normal distribution table. Since z is equal to 1.85 is positive, we refer to the z table for positive values. Also, since 1.85 is equal to 1.8 plus 0.05, we locate 1.8 on the first column, draw an imaginary line or horizontal line from 1.8, and then locate 0.05 on the first row. Draw an imaginary vertical line from 0.05, and then where the two imaginary lines intersect, it shows the desired area corresponding to the left of 1.85 on the normal curve. Here it is 0.9678. So the area to the left of z is equal to 1.85 is 0.9678, or we say 96.78% of the area is to the left of z equals 1.85. Let us have another example. Find the area under the standard normal distribution curve to the left of z equals negative 1.23. First, let us draw the figure. So we have the standard normal distribution curve with the desired area, the shaded part, and that is to the left of the z value, negative 1.23. So this time we're going to use that part of the table showing negative values for z. On the first column, we look for negative 1.2, since negative 1.23 is negative 1.2 plus negative 0.03. So on the first column, we locate negative 1.2, draw an imaginary line, and then on the top row, we locate 0.03, and then draw the vertical line, that's imaginary line. Where these two lines meet is the area to the left of that z value. So these two imaginary lines meet at 0.1093. Therefore, the area to the left of z is equal to negative 1.23 is 0.1093. Or we say that 10.93% of the area is to the left of z equals negative 1.23. Next, let us have example number 3. Identify the area under the standard normal distribution curve to the right of z equals 1.48. Let us have our solution. First, let us draw the figure showing the desired area that is to the right of z equals 1.48. Since z equals 1.48 is positive, we refer to the z table for positive values. Also, since 1.48 is equal to 1.4 plus 0.08, we locate 1.4 on the first column of the table. Draw an imaginary horizontal line from 1.4, and then on the top row we locate point 0A and draw an imaginary vertical line. Where the two imaginary lines intersect shows the area corresponding to the left of z equals 1.48 on the normal curve, and it is 0.9306. Hence, to get the area to the right of z equals 1.48, we subtract 0.9306 from 1. So to get the area, we have A is equal to 1 minus 0.9306. We're doing this because, as we have mentioned, the table shows the area to the left of any z value. Since we are getting the area to the right of a z value this time, then we subtract the area shown on the table from 1. And 1 minus 0.9306 is equal to 0.0694. So the area to the right of z equals 1.48 is 0.0694. Or we say 6.94% of the area is to the right of z equals 1.48. Let's have example number 4. Identify the area under the standard normal distribution curve between z sub 1 equals negative 1.12 and c sub 2 equals 2.08. First, let us draw the figure showing the desired area that is shaded, and this is between z equals negative 1.12 and z is equal to 2.08. This time we have two z values and we need the area between these two z values. And since the table shows the area to the left of any z value, then what we will get from the table is the area to the left of 2.08 and to the left of z equals negative 1.12. Hence, to get the area between these two z values, that's the area between negative 1.12 and 2.08, we subtract the area corresponding to the left of 2.08 minus the area corresponding to the left of z equals negative 1.12. Now, looking at the table, the area corresponding to the left of z equals 2.08 is 0.9812. You can verify this by looking at the table, that part of the table showing positive values for z, or showing the areas for positive values of z. On the first column, locate 2.0. Draw an imaginary horizontal line, and on the top row, locate 0.08, draw an imaginary vertical line. You will see that the two imaginary lines will intersect at 0.9812. Also do that on that part of the table showing areas corresponding to the left of any negative z values. On the first row, locate negative 1.1. Draw an imaginary horizontal line, and then on the top row, locate 0.02, draw an imaginary vertical line. You will see that the two lines will intersect at the area corresponding to the left of negative 1.12, and that is 0.1314. So to get the area between z equals negative 1.12 and z equals 2.08, we subtract these two areas and we will get 0.8498. Hence, the area between z is equal to negative 1.12 and z equals 2.08 is 0.8498. So we say that 84.98% of the area is between z sub 1 equals negative 1.12 and z sub 2 is equal to 2.08. In some cases, we are given the area under the standard normal distribution curve, and what we're going to find is the value of z. Let us have example number 5. Find the z value such that the area between 0 and z is 0.3315. For our solution, let us draw the figure showing the area equal to 0.3315, and that is between 0 and z. By that, we mean z is to the right of 0. So we have between 0 and z. Next, we use the standard normal distribution table to find the value of z. And since the area is between 0 and z, we know that the area to the left of 0 is half of the standard normal distribution curve. So we may add 0.5 to 0.3315 to get the value of z. Hence, we have area is equal to 0.5 plus 0.3315, and that is equal to 0.8315. We're using that part of the table showing the positive values for z, since we have the z value to the right of 0. And since the area is 0.8315, on the table, we locate that value, 0.8315. And then we locate the values that corresponds to this area on the first column and on the top row. On the first column, it corresponds to 0.9, and on the top row, it corresponds to 0.06. Hence, we have the z value as equal to 0.9 plus 0.06. Therefore, z is equal to 0.96. Example number 6. Find the z value such that the area between z and 0, so this time, from left to right, we have z and then 0. The area is 33.65%, or we say 33.65% of the area is between z and 0. Now we're looking for the value of z. For our step 1, we draw the figure showing the area between z and 0, and that is 0.3365. The decimal representation for 33.65% of the area. Again, we use the standard normal distribution table in backward procedure. Since to the left of 0 is half the area of the standard normal distribution curve, and that is 0.5. And we know that on the table, we can find the area to the left of any z value. Hence, from 0.5, we can subtract 0.3365 and the resulting area or value. That one, we can look at the table and locate the value for z. So first, let us find the area to the left of z, and that will be equal to 0.5 minus 0.3365. So we have the area as equal to 0.1635. So we look for 0.1635 on the table and then locate what value corresponds to that area on the first column and on the top row. We draw the imaginary horizontal line backwards and the imaginary vertical line. So we have the z value as equal to negative 0.9 plus negative 0.08, and that is z is equal to negative 0.98. That will be all for exercises on this topic. Please send a message on the FB page given on the description of this video if you would like to get a copy. Thank you for watching. Please subscribe for more math lessons.